Okay, I just want to make a distinction. A lot of people think I do stand-up comedy. I don't. I do improvisational comedy. The distinction is one is a very, very highly prepared, very thorough presentation. The other one is completely off the cuff, bouncing off an audience that you hope has been heavily drinking. I think we're going to do the latter because I don't see my slides here. You found them. Okay, well, we'll get to them. In any case, I'm here to not only convey information, but the real reason I'm up here is I like to get information from the participants here, because that's the way we improve the program. That's the way we make things better. So so I'm going to actually make this a little bit interactive. I'd like to know my audience. So how many people here have been in the SBIR program and either proposed or gotten awards? Wow, cool. And how many people here are new to the program and want to get an award? Okay, very, very good. How many people here have been heavily drinking? Good. Okay, a few, so that's good. All right, so what I'm going to do is really talk a lot about not necessarily the specifics of the technologies that we want, but I want to give you a broad view of the philosophy behind our program, and through that I hope that you'll be more responsive to what we want, you'll understand what we want, and hopefully we'll be more responsive to what you can provide. How are we doing here? Okay, she ran away. I'm just myself. All right, so magic trick. Let's see. So my first slide, I remember this, indicates that we are one of the 4 divisions. You've got the directorates, and you've all seen the other directorates. I guess they're saving the best for last. We're the Science Directorate. In the Science Directorate, we're made up of 3 different divisions. Let's see, astrophysics, heliophysics, earth science, and planetary science. Okay, so each one of these is kind of separately managed, but as you'll see by my slides, they are very, very well interconnected in terms of the science we do and the goals of each of these missions. They're really, really well integrated and interconnected. Got some great slides to show you these things. They're very colorful. Wow.
That's the high tech, right?
So how about that? Let's see. Okay. What else can we talk about? Very, very interesting. Okay. Science Mission Directorate made up of 4 divisions. The goal behind the Science Mission Directorate is, she's running back. The goal behind the Science Mission Directorate is really to provide technologies and innovations that we will incorporate into our program that meet the NASA needs. And the NASA needs in SMD are mainly couched with science traceability. And hopefully we'll be able to show you how that connects. But coupled with that, we want to make sure that what we're asking for is something that companies can provide with the kind of resources available to us in the SBIR program. And that's somewhat limiting because there's not a lot of, huge unlimited amount of money in the program, and there's a certain time scale for the development of these technologies. So we want to make sure that you're able to provide those kinds of things that we want. And then the third thing is we want to make sure that if we ask you for something and you provide it, that we're going to use it. And we're going to help you. All right. Okay, I'm going to get to look at my slides, and we can pass this around. And so the first slide is a word slide. And you may have trouble reading it, so I'll read it to you. And it just says that, all right, we're 4 mission directorates, 4 divisions. We'll test you on that later. Okay, the next slide's a really nice one. I wish you could see it. But it's SMD by the numbers, and there's actually a web page you can find this on. But it tells us that there are 105 spacecraft flying right now with in SMD, 12 CubeSat missions. That makes 117 science missions going on. Hey, we're getting close. Okay. Oh, now I can do this. All right, we have control. Let's conjure up some slides here. All right, here we go. All right, we're in business. Okay, we have 13 balloon payloads. We're all over the solar system. We're all over the Earth. We're all over every place. Sounding rockets, Earthborne investigations, 25 airborne missions, technology developments. We have $400 million invested in technology every year. Over 10,000 scientists funded. Wow. 3,000 competitive selected awards in research. So it's technology development and research as well. Over almost $1 billion awarded between the two. Okay, so there's a very, very rich arena, rich palette of what we do in SMD. Here's that really colorful slide that I thought you would show with the 4 different directorates. Let's go through them one by one. Astrophysics. Somebody yesterday said that, gee, we're developing new spacesuits. What could be more incredible than that? Well, you know, are we alone in the universe is pretty cool. In astrophysics, we're looking at not only the understanding of galaxy formation, stellar formation, what's out there in astrophysics. We're looking at extrasolar planets. There are now thousands of planets found around nearby stars. We are in the realm of finding out, of being able to actually characterize those planets, understanding if they have atmospheres, if they are habitable. So this is one of the areas where we're really trying to understand the context of where we are in the universe. Are we alone? And that's one of the really overriding questions in astrophysics. Earth science. We're really trying to understand the dynamics of the planet we live on. And that accounts for weather, climate change, ice variations, particulates in the atmosphere, pollution, and forest fires, those kinds of environmental issues. And one thing that often forgotten about in the Earth Science Division is we are a very, very dynamic planet, and we have earthquakes. And we know that living here in California. But we actually monitor the Earth and try to do earthquake prediction based on the kinds of inflation and deflation that we can see from Earth orbit. So there's a whole area, a whole arena of the Earth dynamics and geology that we also do in this division. Heliophysics. The sun is the sustaining element for almost all of life on Earth, with the exception of the deep sea vents, which live off chemical energy. We'll get to that in the next one. But heliophysics is, obviously the sun is very, very important, understanding the dynamics, what kind of changes occur on the sun, and how that affects not only the Earth, but the other planets in the solar system, and in context, how learning about the sun can affect our learning about the other stars in the galaxy. 25% of people don't know that the stars in the night sky are actually suns. So it's an interesting aspect. Planetary science. Okay, this is one of the really cool things. That's the Curiosity rover in Gale Crater on Mars. It's Mount Sharp in the background. We are on Mars right now. We have robotic emissaries, extensions of ourselves on Mars. As technology increases, those emissaries become more and more like us. They're more flexible. They're more agile. They can move faster. They can do more and more sophisticated things. We are on Mars in a program which is designed not only to send samples back to Earth, but to understand the habitability of Mars and whether there's ever life there, and whether the life on Earth has ever been exchanged with Mars, or whether whether we are Martians. This is one of the questions that we have in the biological aspects of NASA. Did life evolve on Mars and get transferred to Earth? Did life evolve separately on Mars and Earth? Is there life evolve at all on Mars? These are the basic questions of planetary. In planetary, we're also looking for life, not only on Mars, but in the ocean worlds. And the ocean worlds are very, very exciting augmentation to what's been happening in planetary science. And we have ocean worlds now in several areas in the solar system. Certainly you've heard about Europa and our plans to send robotic spacecraft to Europa. But Enceladus, which is a moon of Saturn, also has an ocean, a buried ocean underneath an ice layer. And there's evidence of oceans on other worlds as well. And we now understand that because of the gravitational flexing of these planets and the introduction of energy into these worlds that keep these oceans liquid, even though they're very, very far from the sun, these are now habitable environments that are actually quite suitable for life, and may be mimicking the kinds of environments that happened on early Earth, where we believe life originated, which is in the deep sea vents. Those deep sea vents, coincidentally, are independent of the sun. So here, habitable environments that could exist elsewhere in the universe, elsewhere in the solar system, that are independent of the sun, which is really, really cool. So I said there was a synergy from, boy, I'm really glad I didn't have to describe this slide too. These are the four elements that we see, the four divisions, and how they're connected. And you can see that, planetary science and planetary formation, connected to the sun, to astrophysics. They're all really, really deeply, deeply interconnected in terms of the science we do. And one of the philosophies we have in SMD, particularly in the SBIR office, is we don't ask for technologies. We don't say, well, today I really feel like nanotechnology. Let's ask for nanotechnology and figure out a way to use it. We don't. We figure out what our problems are, and we're problem solving. And problem solving might be, we want to understand the CO2 environment, CO2 content of the Earth's atmosphere, and that's, how can we best measure that? And what are the technologies we need to apply to do that? So from the point of view of SMD, we don't really care whether you're high-tech, low-tech. We care that you're innovative. We care that you're going to solve one of our problems. Okay, so the goal of the program, and I expressed this before, it's to solicit and select best technical efforts that can deliver what NASA projects need. They can be accomplished by small businesses with SBIR resources and have a high probability of center infusion. Okay, so we create subtopics, and those subtopics all have to have science traceability and an infusion potential. Okay, and one of the reasons why we're here and interacting with you is we want your help in helping us ask for the right things. If we ask for the wrong thing, then you write proposals that maybe don't quite address what we want, and then we're not happy because we didn't get what we want. You're not happy because you didn't get selected. So the real way to do this properly is to have that kind of open communication. So we want to address issues that have the science traceability and address specific needs on NASA. We want to develop appropriate tasks. Again, LK said that we don't want any critical path deliverables. That's true for SMD as well. It's true for everything in SBIR. We want to have an attractive path for investment that you can succeed. We want you to be around in 5 to 7 years when we're going to be using this technology. And we want to encourage a sustainable supply chain. And this is really, really the important aspect. We want to make sure that you're going to be healthy during this whole time, and we're going to be able to use these technologies. We want to balance the portfolio. And one of the interesting things is we want to make sure we have a mix of commercialization is really one of the things that we're asked to do. But the reality of it is that we were strictly about commercialization, we'd wind up with a procurement program. We'd ask for things that we know you can deliver and we know we're going to use. But innovation tends to drive us a little bit away from that. So we have to strike this proper balance between getting something that's very, very innovative, which we have trouble doing in NASA. We're a very, very large, very, very conservative engineering organization. At the agility of small businesses are really where the heart of innovation comes in. And this innovation is really, really important because innovation leads us to very, very high return on investments and the ability to enable new things for us. So we really want to make sure the heart of that innovation stays in the program. That's certainly one of our goals in SMD, and we'll force the program to be innovative where we can. I talked about science traceability. I want to just go into that a little bit and what that means. SMD has a unique benefit. We have lots and lots of committees on the outside that tell us exactly what we ought to be doing and give us roadmaps and decadal surveys and things like that. These advisory committees basically tell us what steps we need to take in the future, and we use those to ask for technologies. So survey data is very, very important. The resource, this link over here gives you the first step, and it's kind of a tree of technologies and reports. So this is a really, really good place to start in terms of understanding what these surveys are telling us. And this is really, really the heart of what we do in the program. So here's kind of a list of the 4 different divisions and a list of the decadal surveys that we're following. And you see that about every 8 to 10 years, a new decadal survey comes out, and they're always coming out. Science community is always being asked to participate in these things. These are really important documents to read and understand in terms of what are those specific questions, what are those NASA needs. Remember, NASA need is really the bottom line reason for selecting these things. So I invite you to take a look at these things, take a look at that web link, and follow that and try to understand that. In terms of success stories, here's a few success stories. These are 6 different technologies that are flying on Mars today. Curari is a company that makes a vacuum pump. That vacuum pump is spinning at 100 RPM on the surface of Mars right now. Wouldn't you like to have your name on one of these slides? Isn't that really cool? These are the kinds of things we really love to brag about. This is going on Mars. This was on Mars a few years ago. This is the Phoenix lander. They had 3 SBIR technologies. This is the Aurora mission, which is understanding the chemical content of the Earth's atmosphere. It's got 4 SBIR technologies, including one that is a service. Remember, we can be services too. SBIR technologies don't necessarily need to be a piece of hardware. Okay, so your name here is what your goal is. This is the last 10 years of history of the SMD awards, and I just want to point out that for the last 4 years it's been fairly stable. We have about a 25-27% selection ratio for phase 1. It's good, but not all that good. I will guarantee that there will be disappointed companies that will get back feedback from us that say, your outstanding reviews, technically superb, commercially very, very viable. It's technology we'd really love to have, but unfortunately we couldn't select you because there is a finite amount of money in the program, and we can't select all the superb proposals that we get, and that's one of the unfortunate things. Selection ratio: if you get to phase 1, you've got close to a 40% chance of getting a phase 2 proposal. And there you've really become a member of the club, and we will nurture you and cherish you and help you succeed, and you'll have all these other programs available to you. So to that end, I'm going to ask you another question, and the question could be, do you want us to increase the size of the phase 2 awards? Okay, and everybody's going to say yes, right? Would anybody not say yes to that? But that's not the question. There are really 2 questions. And one of them is, we have the opportunity to increase the size of the phase 2 awards more than they are now. They're $750K for 2 years. If we do that, however, because we have a finite amount of money, we will have fewer people participating in the program. We'll have fewer phase 1 and phase 2 awards. Okay? So the real question is, would you rather see us increase the value of the phase 2 awards, or would you rather have us keep the phase 2 awards at the current level and maximize the participation in the program? Okay? So increase the level of the funding. 1 person. Maximize the participation. Wow. Wow. Okay. There are people watching and listening in the audience on that. That's it. That's very interesting. Thank you. Okay. Here are this is a list of the subtopics in SMD, and I could spend the next half hour telling you individually what each one does, but I think it's more important to just kind of go over in a broad brush sense of what we have. We have 5 general topics, and the topics are sensors, detectors, and instruments. And this is our biggest topic area, and there's a wide variety of subtopics there. I'm going to just point out a few of them. Obviously, there are the direct sensor technologies. Down in toward the bottom, 1.10 is atomic interferometry. It's a fairly new subtopic, and it's very, very broad-reaching, very, very innovative, and very, very successful. The subtopic manager came to us and said, I want to do this new subtopic. I've got 4 companies that I think would propose to this if we had this subtopic. He did his homework. We put it in. 4 proposals were submitted. I think 2 were selected. 1 was selected for phase 2. So that's what we really want. We want to understand that there are companies out there that can supply us with the kinds of technologies that we want if we ask for it. We have 2 new subtopics in that area, in that topic, and that is their ocean world subtopics. And we had 3 altogether last year, and we had a little misfire on one of them. We're probably going to combine them, but we're really looking at very, very enthusiastic about continuing the ocean world's new subtopics. Advanced telescope systems is another area, and this is where we're looking at telescope systems to augment what we have now. A lot of that work is done for star shade and looking for extrasolar planets. Spacecraft platforms and subsystems. Here's areas where these kind of the standard navigation and thermal control systems, things like that. One of the issues that we have are that suppose you're small sats. Suppose you use small sat propulsion. Do I show up in a small sat subtopic, or do I show up in a propulsion subtopic, or is it some area in between? And one of the other areas that we're struggling with is right now, if we write these things and then throw them over the fence, you propose to them, and then we get them back. And what we would like to do is we would like to be able to say, well, gee, this proposal was submitted in one subtopic, if it really might find a better audience in another subtopic. We'd like the ability to be able to shop proposals around, not often, but when clearly there's a better path to it. And the lawyers get involved in this, and we have to fight that battle. These people at higher salaries than I do would fight that battle. But the real question to you is, and I think we asked this in the RFI, is that something you'd like to see? You'd like to see us have that ability to shop proposals around? And a lot of nodding heads. Okay, so that's another thing that getting feedback. Okay, robotic evolution technologies, the robotics, another really strong area. I told you these emissaries that we have on Mars are increasing in capability. We're doing some really amazing things in some of these areas, and we want to continue that Moore's Law continuing increase in capability, and we want to make sure that that continuing increase in capability winds up on the surfaces of these other planets. And finally, one of the areas that is one of my favorite areas, information technologies, and I think we can do a better job in providing better structure in information technologies. If you look at aerospace industries, about half the money spent in some of these projects are on software and information technologies. We don't spend that quite ratio in NASA, and I think that's to our detriment. So I really would like to see more topics in the area of information technologies. Come talk to us if you've got ideas. One of the problems I expressed earlier is that sometimes in information technologies, particularly things like cybersecurity, happen so rapidly that you've got to find a way to fit those kinds of technologies in the life cycle of an SBIR proposal cycle, where you've got almost a 3-year cycle between asking for something and getting through phase 2. So again, advice from companies on that is very welcome. Okay, so I want to talk a little bit about potentially new subtopics. And I mentioned life detection in ocean worlds is one area that we're really interested in. And in life detection, there are really 3 elements of life detection. You've got to collect the sample, and sometimes this collection of samples is very difficult, very challenging. You've got to concentrate the sample, get the elements out that you want, extract the water, extract the organics, extract the elements that you want, because sometimes the concentrations are so small that you want to really increase that in order to get to a detection limit. And then finally, you want to do life detection. Coupled together, we're starting to talk about things like smart protocols. Particularly in life detection, you may collect the sample and do the analysis, and you'll get a result. And depending on that result, you may want to do something different. You may want to branch off and either reanalyze the sample or do something else. And we want to be able to understand how our future instruments that we're going to fly are going to be able to accommodate these very smart protocols where you've got this branching. Again, these are opportunities for SBIR companies to participate in this, because it's a very new field. We're looking at integrated systems on a chip. This is something that we have tried at JPL and been very successful at, building spectrometers the size of your thumbnail. And last industry sessions, several companies, I asked the question, do you have that kind of capability? Because we work with Broadcom and use a lot of the capabilities that these very big companies have. They don't use anymore. They don't use these technologies developed for iPhone 4. Okay, so they very nicely hand these things over to us, and we're able to actually cobble these things together. And we're really interested in understanding whether small businesses also have these kinds of capabilities to help us do this, because this is very vital. Particularly the systems on a chip and the integration of science instruments within the small CubeSat environment. Remember, a CubeSat can be like can be like a cell phone. Okay, and a cell phone's got everything except propulsion that we could use for a CubeSat. So we really want to be able to integrate things at that kind of level and be able to fly these very, very sophisticated instruments on CubeSats. So again, we're looking for participation of small businesses in these realms. And maybe it's premature to ask, but if there is a thread that we can start pulling on, we'd like to know if we can do that. Again, information technologies and cybersecurity, I asked for that before, but it's on our list of things we want to consider for new subtopics. Okay, I mentioned commercialization versus innovation, and you know, we have this kind of notion in SMD of asking for parts or asking for ideas. And if you ask for parts, you know, it's pretty highly specified. It's something that you can write down requirements on. It's usually higher TRL levels. Usually there are no surprises. Usually you can have a higher probability of commercializing. But it's not always the whole picture. A lot of times we want to ask for ideas as well. And ideas are not as well specified. We specify goals rather than requirements. And they're usually lower TRL. They potentially have a higher perceived risk, not necessarily a real risk. You can get surprises, you can get disappointments, but you can also get very, very high returns on investment. So the question is, how do we balance a portfolio between asking for parts and asking for ideas? Sometimes if we ask for ideas in subtopics, we wind up with unhappy people who say, well, this is too broad, we don't know what to apply for. So one of the balances we have is we can ask for ideas now, okay, before the solicitation. We can incorporate those ideas into our subtopics in a much more specific sense, okay? So if you've got an idea on how to solve a NASA problem that is very, very innovative and very different. You know, I said, you know, suppose you wanted to find the CO2 balance in the Earth's atmosphere. You know, we want a spectrometer that has so-and-so requirements, and this is the part we want you to build and provide for us. But somebody else might have an idea, well, you know what, I can develop a service that takes ground-based data, correlates it, and can establish or get you a very, very good handle competitive to remote sensing using that data. And that's really cool. We'd love to hear that. We'd love to hear ideas like that. So I just made that up, but that's kind of the thing that we're really looking for. And I think now is really the time to express those ideas so we can better incorporate those into our subtopics. So please help us write subtopics. Help us be more responsive so you can be more responsive. Okay, so the evaluation criteria for what we look at, and this is evaluation criteria not for SMD but for NASA in general. And I just wanted to read a specific part of it is NASA will give primary consideration to the scientific and technical merit, the feasibility of the proposal, and its benefit to NASA interests. And I'm going to talk about benefit to NASA interests in a little bit because that's really a bottom line, and we'd really like to see you express that in your proposals. Okay, tell us what your technology's value to NASA interests is. Okay, so what are NASA interests and what are they determined by in SMD? Certainly they're determined by the science goals. Okay, so understanding what our science goals and basic questions is really, really the important thing in understanding what our interests are. It's also mission requirements, specifically where we're going and what we're trying to do. And those mission requirements are also very, very well articulated. They will be articulated in our subtopics and links within the subtopics. And also NASA programs. If it's not a specific mission, it may be a NASA program that will do this as well. Now, things change. Things change from day to day, and it's the programmatics that happen when we're selecting proposals that really somehow will sculpt what our portfolio will ultimately look like. And those changes can be new discoveries. And we have new discoveries all the time from our observatories, from our lab results, and from our missions. Everybody's aware of the discovery of gravitational waves, right? Everybody heard about that? Two gigantic black holes, tens of solar masses in diameter, collided within 1/100th of a second. Four solar masses of energy were converted into gravitational waves, propagated out. That happened 1.3 billion years ago. Those waves actually crossed the path of the Earth one day after the instrument was turned on. What a coincidence. And those gravitational waves distorted the Earth by 1/1000th diameter of a proton. And that was unbelievably measured and it has revolutionized the field. It has opened up a new field of astronomy in gravitational wave detection. We now have, I think there are 5 fairly robust detections so far. The instrument is operating right now at higher performance. And this is a really new field. And the fact that these are very, very large black holes colliding has opened up a whole new realm of understanding potentially of what dark matter is going to be. These are potentially primordial black holes of a size that we didn't have in our equations, in our theories. So again, you know, a new discovery can open up a whole new realm and a whole new realm of new technologies that we want. So, you know, read your newspapers and be aware of these things. There's other news than Donald Trump in the so speaking of which, also new canceled and delayed missions will sometimes sculpt what we determine for our portfolio, and of course politics, mandated changes to national priorities can potentially change what we do. Hopefully for the better, not for the worse. So I teach a class in proposal writing, so I can't help but give you some proposal advice. So to that end, and then this is, I think this is proposal advice. I wrote this for SMD, but it's probably more general as well. But review, the thing you want to do is you want to review prior year solicitations. Okay, that's the best way you can get a handle on the kinds of things that we want. Okay, search and identify specific technical areas, subtopics, and look for the lead centers of your interest. Now remember, subtopics will change. In SMD, they don't change very often, but maybe 90% of them will remain the same, but we will, maybe 80% of them will remain the same. And we'll rotate some in, create some new ones, rotate some out, either temporarily or unlikely, but permanently, but usually we rotate them in and out. Request subject matter experts. Technical information, you've got some phone numbers and emails in the back of your booklet. Find out where the lead centers are, where these centers of information are, and request that you get in contact with the technical experts. You can do that now. You can't do that once the solicitation is out. We just cannot talk to you. So right now, the fact that you're here in this room or listening to my voice is the right thing. Email, again, call the points of contact and the thing. Learn the technology, learn the priorities, visit brief NASAs. You're doing that right now.